So now we are looking at sector and arc length. So if I have a circle like this, and then this is the center. For those of you that eat pizza, sometimes you have to cut the pizza like this, right? So if you cut the pizza like this, probably you're going to take this part out, okay? Now, this space here is called a sector. So if you cut this circle, this portion here is called a sector. And then this line from this point, let's call this point A to point B, and let's call this 0. So this length from here to here is called arc length. Or you can simply call it arc of the circle. Either I call it the arc length of the circle or the arc of the circle. So this space between 2 points is called the arc length, and then this space here is called the sector. Okay. So we can explain the arc length as a portion of the circumference. Remember, the circumference is this entire line. That the entire line is called the circumference, while the sector is a portion of the entire area, because this entire space is the area, but this portion here is just a part of the entire area. So a sector is a part of the area, while the arc length is a part of the circumference. Okay, so this helps us to get the formula for the sector and the arc length. Okay, so here there's an angle here, we call it theta. So if you've learned about circle and angle around a point, the entire angle here is equal to 360 degrees. So this is just a portion of 360 degrees. So the formula for the arc length is equal to theta over 360 degrees times 2 pi r. So that's the formula for the arc length. Remember, 2 pi r is the formula for circumference of a circle. So since the arc length is a part of the circumference, so the formula is theta over 360 times 2 pi r. The formula for sector is equal to theta over 360 times pi r squared. Theta over 360 times pi r squared. Also remember, the sector is a part of the area. So this entire space is the area, but this portion is the sector. So that's why theta over 360 represents the portion that is covered by the sector. Okay, so pi r squared is the area. Theta over 360 represents the fraction of the area. Okay, so the bigger the angle, the bigger the value of the sector. The smaller the angle, the smaller the value of the sector. So remember, the line from the center to the circumference is radius. Also here is radius. Okay, let's look at an example. So now we're expected to calculate the arc length and sector of the circle below. So we have this situation here. So let's calculate the arc length first. So I'm going to try to use this space. So the formula for arc length is equal to theta over 360 times 2 pi r. So we know that theta is this angle here, which is 115. So we simply have 115 over 360 times 2 pi r. So 2 times 22 over 7 times our radius is 8. The radius here is 8. So what you're going to do is multiply all this numerator together. 115 multiplied by 2 multiplied by 22 multiplied by 8. What will you get? 40,480. So 360 multiplied by 7, 2,520. Okay. So now you can divide 40,480 divided by 2,520. 16.06. So that means this arc length, this length here is 16.06 centimeter. So I'm going to write it here. 16.06 centimeter. Remember, for the arc length, we used the circumference. Okay, so let's look at the sector. The formula for sector is equal to theta over 360 times pi r squared. So that's the formula. So we know that our theta is 115. So we have 115 all over 360 times pi is 22 over 7 times our radius is 8. So 8 times 8. 8 times 8. So let's multiply all the numerators. 115 multiplied by 22 multiplied by 8 multiplied by 8. We have 161,092 all over 360 multiplied by 7. 2,520. We've gotten it before. So we divide 161,920 by 2,520. 64.253. Okay, so let's just call it 64.3. So this sector is 64.3. So what would be the unit? When we calculated for the arc length, the unit was in centimeter. But for a sector, since the sector is part of the area, the unit is going to be in centimeter square, because the sector is part of the area. We are done, but I'll leave you guys with a question that you can try later on. But I think we are done with this question. So I'm going to leave you guys with a question to try out later on.